Welcome to section 2.3. Here we're going to learn about constructing truth tables. So truth tables are very, very important as we move forward. You can see that they're here right towards the beginning of the section. What we've learned so far is we've learned about statements, and that was the very first section. And then we learned about compound statements. Truth tables help us to look at the truth value of a compound statement. And so that's their value. What we're looking to do ultimately is just have a decision-making tool to tell whether something is a valid argument in the end. And we do that by looking at the truth values. And so as we went through section 2.2, you saw that there were some compound statements like and, or, and the negation they consider to be a compound statement, although it's very simple. So we want to look at those. We also saw what they call the conditional. And if you remember what the conditional is, that's the if-then statement. And then there's the biconditional. And that's the if and only if that they shared with us back in 2.2. Now, as we move forward, section 2.3 is going to handle these three, and, or, and the negation, those three truth tables. And 2.4 is going to handle the conditional and biconditional and establish the truth tables, and then we just use them. So essentially what we're creating, for lack of a better way to say it, is a multiplication table. So if you were in a class and you didn't know what 3 times 6 is, one of the things you could look at would be a multiplication table that would have 1, 2, 3, 4, ... And then across the top, 1, 2, 3, 4, 5, 6. And they would be all filled out. So in this row, you would see 3, 6, 9, 12, 15, 18. And so if you didn't know what 3 times 6 is, you would go to 3 and 6, and you would look at what was at the intersection and be like, oh, 3 times 6 is 18, right? We have calculators, but if we had a table, a multiplication table, it would give us the same information relatively quickly. That's what truth tables can do. They're basically a guidepost, something that helps us know what happens when we put two things together. So you'll want to memorize these and then use them over and over and over again. So let's start with something that would be relatively easy, the negation. So when we have a truth table, it puts out always a general letter for a statement. Now with the negation, you're only negating one statement. And so as we look at negating a statement, we only just have one, so we have just the statement P. P is what I call a dummy variable. It represents any statement. And that statement can either be true or it could be false. And so the truth table for the negation of P says, well, if P is true, so the first row here is, if P is true, then the negation of P is false. If P is false, then its negation is true, something that you already kind of know and we established. So there's the one for the negation. All right, so if we know a statement's true, then its opposite is false. If we know a statement's false, then its opposite is true. And so we use that to our advantage. Now for, let's do and next. And we'll do or right next to it. So with and, you're joining two statements. We're going to give those two statements letters, P and Q. In your problems, they may have more than one one letter involved there. I apologize. They may not use P and Q. They may use R and W, S and T. That's okay. P and Q are just dummy variables. They represent the first statement and the second statement. And remember what the symbol for and is. And is that upside down V. Now, what we need is every possible combination of P's and Q's. So P could be true, or P could be false. So the way we establish it is true, true, false, false. And Q could be true, false, true, false. This is how every truth table starts with us. It's always true, true, false, false, and then Q is true, false, true, false. What that does is it gets every possible combination of P being true and Q being true. because as I look here, here being these first two, this is saying if P is true, then Q could be either true or false. If P is false, then Q could be either true or false. So we're just really trying to exhaust every possible combination that's there. I'm going to draw some lines in here so that it's a little bit more clear when we write our answers. So we need to establish what does it mean for P and Q? What would its truth value be? So I'd like you to visualize a situation. Let's suppose you walk into a classroom and you want that person to be teaching math and the professor to be a woman. Now, you want that person to be teaching math and you walk in and being a woman. Both have to be met with the and statement. So what the first line says is you walked into the room and the person was teaching math, that's P, and the person was a woman, that's Q. So if both are true, if you walk in there and it's a professor teaching math and that professor is a woman, then everything has been met. If you walk in there and they're teaching math, that's great, but they also have to be a woman. So when it's not a woman, when we failed at being a woman, then we failed overall. When you walk in, they're not even teaching math, you fail. And when you watch in and you're not even teaching math, you fail, because and needs them both to be true. So you should make some observations here. In an and statement, in an and compound statement, both have to be true for the whole thing to be true. If any one of them is false, the whole thing is false, right? And so we'll just be anchored in these guides right here as we do our work. So and needs them both to happen. So let's look at or. So we have P and Q again, and it's always the same. True, true, false, false, true, false, true, false. Whenever we have to establish a full truth table, we're doing it just like this every time. Your homework does a really good job of piecing things apart. Okay. And then or, remember that has the symbol V in there, P or Q. So now if we walk into the classroom, we'll be happy if it's a woman. Let me keep it in the same order. We'll be happy if it is somebody teaching math or a woman. If either one of those are met, we're happy. So we walk into the classroom, the very first row, I'll put a 1 there, is saying, well, we saw somebody teaching math and they were a woman. Well, the whole thing's true. We were successful. The second one, you walk in and they're teaching math, but they're not a woman. Well, we're still successful because of the word or. If either one of them is satisfied, we're happy. So we walk in and they're teaching math. Awesome. We automatically are successful. We walk in and they're not teaching math, but they are a woman, so we're successful. The only way we're going to fail in an or is if both conditions aren't met. You walk in and it's English being taught by a man, right? And so it is not successful there. So with the or, the only way it's not true is if both conditions aren't met. And so giving yourself language like that would help. Hey, for an and statement, they both need to be true for the whole thing to be true. If any one of them's false, the whole thing's false. For an or statement, if any one of them's true, the whole thing's true. So an or statement is mostly true, an and statement is mostly false. So what's the homework going to be like? We are going to come back into these charts over and over. These are like our multiplication tables when we don't have our multiplication values memorized. So here is an example of what's in the homework. They give you, in the homework, they give you this. P. So this is like questions. Let me get a reference. This is going to take you from 6 to 20 in the homework. And so what they tell you is P is the statement, 1 plus 2 is equal to 3. Q is the statement, 5 is an even number. And R is the statement, 7, keep this, 7 is a prime number. So what do we care about? We actually don't care about the statement itself. They want us to determine the truth value. So let me fix something really quick that's bugging me. They would like us to determine the truth value of a statement like number 8, which says P or Q. Yeah, I'm not going to say the V, right? P, V, Q. That's not what you should be saying, P or Q. They would like to know the truth value of P or Q. Well, we don't actually care about the statement of P, Q, and R. We care about their truth value. So P is true. Don't you agree that 1 plus 2 equals 3? Q is, well, is 5 an even number? No. Q is false. And R is 7 is a prime number. Okay, so if you didn't know that, you would look that up, but 7 is a prime number. So essentially they give me these statements, but I don't really care about them other than to evaluate them. And so what we have is a condensing. P is true. Q is false. And R is true. Okay. And let me keep my symbols the same. I'll make that a capital T there. Everything else we don't care about anymore because we looked at it, right? So if they tell us P is true, Q is false, and R is true, they would like us to know, and I'll write 8 a little bit higher. That way we can see these truth tables. They would like us to know what's the truth value of P or Q. Well, here's how you would do that. You would care about the truth values of each. So I'm going to use a different color when I evaluate. So I'll use blue. What is P? P is true. Or was there from the beginning. And what's Q? Q is false. So let's look. We have a true or a false. Remember with an or, if one of them's true, the whole thing's true. Or you could come up here and see, well, where are we? We're right here. We have a true mixed with a false. And what's the result of that? The result of that is true. And so we have our answer. Our answer to the problem is true. Why? Because, and let me draw a line here. Oops, draw a line here. Because in the second row, where we had a true V false, the overall answer was true. Now why? Because in an or statement, if one of them's true, the whole thing's true. So what's it going to look like as we move forward? What about number 13? Oh, let me not do 13. Let me go to 14. 14 has Q, V, negation of R. Okay. Well, let's be careful here. Let's do it one at a time. How about Q? What's Q's truth value? Well, it's false. Okay. I'm going to leave in black what hasn't changed. Now, I would recommend just doing this right at the same time. What's the negation of R? Well, R is true. So the negation of R, if we have a true statement, the negation of it is false. So now I have a false or false. Well, let me go to my or statement and let's look for the two falses. And what's the result? The result is false. So this is false, and we would circle false. So the answer for 8 is true because you had a true mixed with the false. You had something that was true. And the answer for number 14 is false because both of them were false. And you're just playing this game and you get really good at it over and over and over again. So I'm going to erase this. And let's keep looking. So we are at 14, still pretty nice. Let's look at something like 16. Oops. As we look at 16, here's what 16 says. P or Q or, and R. That's what it has. So when you have something long like this, you just handle it one at a time. So the first thing I would suggest to do is put in the truth value. So I'm going to just put what's there, and let's go put in the truth values. P was true, Q was false, R was true. So if you remember your order of operations is what I want to say. It's not what they called it in the end. They called it like, let me go, I'm going to go look. Yeah, dominance of a dominance from least to most dominant. And so you would do parentheses first, then the negations, like we did with the last one, did the negation first. I want to remind you that these compound statements here of and or, they tie each other. And so when they tie each other, we work on them in order from left to right. So the first thing that we're going to do is just consider this. So hopefully with your experience, you'll start to realize, hey, this is an or statement, this first one right here. It's an or. And in an or, if one of them's true, the whole thing's true. So these two right here produce a true statement. And now we have true and true. Okay, so those two right there are true statements. So you just basically do things one at a time. It's very much like order of operations in arithmetic. So now you have a true and true. So what is that? Well, I go to my and table and I'd look for true and true. And there it is in the first row. And it's telling me the result is true. It's the only time an and is true is if they're both true. And so we get the right answer coming out of there. And we have a nice true statement. And that's our answer in there. That's what your homework's going to look like as we go through. Even up through, you can be like, well, Jensen, what's it going to be like for number 20? And here's number 20. The very last one in there, right? Because we went from 6 to 20. Here's 20. The negation of Q and R and P. Again, we're going to do it from left to right, but I would recommend putting in the negation right away. So the negation of a false statement, Q is false. The negation of Q then would be true. We have this and that's going along for the right. R is true, and P is true. Oh, sorry. P is true. I meant to write true in there. So true and true is true. We just saw that. And then this stuff just gets brought down. True and true is true. So we can think that it's going to get harder along the way, and it's not. What happens is more and more reinforcement. I am erasing these only so that I stay very close to the truth tables. And I know that you can back up the video in there. So it is something that takes getting used to, but it is relatively straightforward if you're seeing it for what it is. If it's not straightforward, just what you need to do is ask some questions to me and let me see how you're thinking, and then we'll just adjust. What happens in the next group of problems is pretty nice. You have basically the same thing, just not in words. So here's 24. 24 gives you a table that looks like this. It has P, Q, R, negation of P, negation of R, negation of P and Q, the negation of P and Q, and negation of R. Sorry, that's the negation of R over there. I know that's not really readable. So that's what we have so far. And what they're trying to show you is how to do a very complex one. If you had a huge statement, you would piece it apart. What they're telling you is that P is false, Q is false, and R is false. So everything in black is what's given to you. So now that we just got to go, and we literally go left to right. Everything is building up to that last statement. So the negation of P is true, right? If P is false, the negation of P is true. If Q is false, oh wait, we're not, the negation of R. R is false, so the negation of R is true. So the negation of P, true, right? So we're taking this one, and Q, false. So it's an and statement. Oh, apologize. That's an or statement. The negation of P or Q. So that's an or statement. And if one of them's true, the whole thing's true. So the negation of P is true, so it doesn't even matter what Q is, the whole thing's true. And then we have another OR statement. We have the negation of P or Q. Okay. And the negation of, or sorry, I keep saying and, or the negation of R, right? Everything's an or statement, or the negation of R. So that's a true or true. The whole thing is true. How do I know? Because that's right here, right? True or true is true. Again, where did I go to see that? I went right up here to see that. Okay. And so that you're basically just completing that truth table in there. Okay. What happens at the end is you're creating full truth tables. You do it on your own. So we're going to create a full truth table. It's not letting me choose black. Okay, looks like I'm locked into a color here. Not sure why. But in 20, let's look at something like 28. In 28, here's what they give us. They give us the negation of P or the negation of Q or R. And here's what they tell us. They tell us P, it's kind of combining the first problems we did with what we just did. P is all triangles have two sides. Oh, sorry, have three sides is what they actually have written there. Q is some rectangles are not squares or not square. And R is a pentagon has 8 sides. And again, what do we need to know? We need to know the truth values of each. Let me see if it will let me switch colors. The answer to that is no. Okay, so what's P? All triangles have 3 sides. P is true, right? P is true. Q is some rectangles are not squares. That's true. And pentagons have 8 sides. Nope, pentagons have 5 sides, so that last one is false. So out of all of this, we know P is true. And maybe this is the best way to do it. P, Q, and R. P is true, Q is true, R is false. And what they would like us to do is the negation of P, or the negation of Q, or the negation of R, right? This is our main ask, what I just circled up at the top, right by 28. So when you have a compound statement like that, if there's any negations, we want to do those first. So we're going to figure out the truth value for the negation of P, the negation of Q, because we'll need them along the way. If P is true, then the negation of P is false. If Q is true, then the negation of Q is false. Okay. And then what's next? What would be next in our work? And I'll highlight it. It's going to have to be in red because it won't let me change the colors. That's what's next. I got to do that first or. So the next thing that we need to do is do the negation of P or the negation of Q. And so when we do that, we are looking at the OR truth table and reminding ourselves about the OR, which is over here on the right. As long as one of them is true, the whole thing's true. But the negation of P and the negation of Q are both false, so this is false. It's that last column right down, last row right down here, right? And so we get a false in there. Now look at how I'm going to write this next one. We just did the negation of P or the negation of Q, and now we got to OR that with R. Okay, and so really what we have are just two truth values. We have a false being ORed with a false. And we know from what I've worked just a second ago that false or false is false. And so the overall answer here is false. That's what they'd like us to do. So that's the answer to our question is false. And we have to build up these systems in order to make that happen. The last group of problems, they have them split into two, but in the the ask is the same. The ask is for us to do a full truth table. So let me give you an example. Here's number 32. Number 32 simply says P and Q or R. They would like us to do a full truth table for that. So let me model how that's going to go. And they do a great job modeling it in the book. Whenever you have to do a full truth table, you need to exhaust all possibilities for P and Q being true or false and how that would match up. So again, the way to do that is true, true, false, false for the P, and then true, false for the Q. That makes sure that every combination is hit. You saw this in your probability. Now, I would look at what we're asked to do and think about what would happen first. There's no negations to take care of, so the very first thing to happen, and I really apologize, I can't change colors, but this is P and Q would happen first. So that's the first thing we're going to do. And then the next thing we're going to do is realize that we'll have the truth value for what's highlighted in red. So then I'll put that in parentheses just for emphasis. We'll have that truth value, and then we're going to OR that with the R. And we'll be done. Whatever comes, this filling out this column, this last column will give us the ending values for the truth table. If they're all true, then we call it valid. And they may ask that in this section. But let's handle this. Let's do the P and Q first. So remember with the and, let's go up and look at it. With an and, which is this guy right here, right over here on the left-hand side, they both need to be true in order for it to be true. If any one of them's false, the whole thing's false. So when we do P and Q, it's going to look exactly like that original truth table because there's really no difference. It's going to be true, false, false, false. True, false, false, false. Why? Because in an and statement, if any condition's not met, then the whole condition's not met. So we get true, false, false, false. Awesome. So now we're going to take the true, false, 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 the P and Q, and OR it with the R. Okay, and I just realized I have a problem. I told you that I wouldn't assign a problem like this, and I haven't. This happens to be an even problem. So I'm going to do something, I'm going to change it, 32 modified. Let's OR it with P, with P again. That's what happens in your homework assignments is I just stick to 2. If there was an R, I'd have to create an R column, and I would essentially have to put 8 rows in there in order to exhaust all the ways P, Q, and R could intersect together and have different truth values. So let's just change the original problem to a P. And so we're going to OR it with a P. So we're going to take this column and OR it together with this column. So remember with an OR, as long as one of them's true, the whole thing's true. Right? So if we look at our OR statement, which is right over here, as long as one of them's true, the whole thing's true. So if we're ORing these two columns together, the P and Q column and the P column, we OR them together, true and true is true. False and true is true, but false and false is false, false and false is false. They would not call this a valid argument because not all of the ending values are true. Okay, and again, I apologize for grabbing one that had 3 in it. I know that your homework does not include that. So let's take a look at something like number 34. Right, this is later. but still the same. 34 says P and negation of Q. How do we start out? Always the same way whenever we're asked to do a full truth table. True, true, false, false. True, false, true, false. You really want to do your homework so that you feel the flow of all this. So we always look at the original statement. P is there, and we have truth values for P. Negation of Q is there. We do not have values for the negation of Q. We highly recommend putting those out and not trying to do it in your mind. We watch too many people make mistakes there. So if there's ever a negation, we want those out right away. That was modeled when they gave you these examples like for 24 or what we did with 28, right? We got those negations out first. So negation of Q, Q's right to the left of it. So Q was true, so this one's false. Q is false, true. True is false, false changes to true. So it's false, true, false, true. So now we're doing P and the negation of Q. Get rid of that mark there so it's not confusing. So P and the negation of Q. So I'm going to do something because I can. It's like this column right here doesn't even exist. We don't even care about that. We're just looking at these two columns in here. And we are going to AND them. So in an AND, as long as somebody's false, the whole thing is false. Let's go remind ourselves about that. Here's AND over on the left-hand side. If one of the things is false, the whole thing is false. So in the first row, we do have a false item, so the whole thing's false. In the second row, we got a true. Both are true. Third column, both are false, but one of them's false, so the whole thing's false. And the last one of them's false. They would say that this argument is not valid. The reason why it's not valid is because not all the ending truth values are true. To have a valid argument, we'd have to have true, 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 true. That's what's happening as you go through this exercise set. We're getting comfortable using truth tables, right? So as a reminder, truth tables always start out the same way if you're having to create the full truth table. True, true, false, false. True, false, true, false. Then you're building columns based upon what you see. So if you saw something like P and Q, or the negation of P and the negation of Q, then you would slowly build. You would look for any negations that are involved. And you do have a negation of P involved and a negation of Q. You would get those truth values out. Then you would go and say, well, what would you do next? And what we would do next is that first parenthesis, P or Q. And you get the truth values out for that. Then you say, what would I do next? And what you do next is the negation of P and the negation of Q. And what would you do last? You would put those two parentheses together. And you just build it. We're always looking at true truth values at a time, right? So what's in here is that full statement right there. And how nice can it be? It can be really nice. Great, it's allowing me to switch colors now. I'm not sure why. So the negation of P. Well, P's that first column. Well, we know that. It's false, false, true, true. Negation of Q. False, true, false, true. P and Q. Okay, here's P and Q. So I'm looking at these two columns right here being ANDed together. And it's just my regular truth value. With AND, they both have to be true for the whole thing to be true. So I get true, false, false, false. Over here, negation of P and the negation of Q, right? So what am I doing? I'm not looking at these columns anymore. I'm looking at these two columns with the same AND. So as long as one of them's false, the whole thing's false. And I get that guy. And now I have an OR. And the OR is between these two columns right here. And the OR says if somebody's true, the whole thing's true. So the first one's true, but there's nobody true here. There's nobody true here. And there is a true statement here. And so we go through that process and we find that we don't have a valid argument because we have some falses involved in the end. We don't have a valid statement, right? I shouldn't say argument, I should say statement is not valid, because in order to be valid, everything would have to be true there. Hopefully this will resonate with you. The only way to really know is to go in and do and then ask questions. So